We are moving into chapter 4. And the whole chapter is about quadratics. Okay, what do you remember about quadratics? It's an Algebra 1 topic. Parabola. What's a parabola look like? It's a U. It's a U. Okay, as Maggie's back there drawing it with her fingers, right? Okay, so parabola, U shape. What about the equations? When I say quadratic, what's true of a quadratic?
It's squared.
There's a square in it, right? Yes. Okay. You guys are doing good. This is good. I'll be honest. It's been a little rough today. Like Algebra 1 and quadratics and parabolas, it's not really there in a lot of memories today. So that's what we're looking about. The beginning of this chapter, so like 4:1 and 4:2, we're doing a lot of graphing. When we get into the second half of the chapter, we'll be working more with solving. Okay? So we'll relook at those techniques. Quadratic function is of the form f of x equals ax squared plus bx plus c. So that right there, that ax squared plus bx plus c, is what we call standard form. That is the form you probably worked most with in Algebra 1, would be my guess. That ax squared plus bx plus c. A quadratic's graph is a parabola. We discussed a moment ago that that is your U shape. The function above can be written in the form f of x equals a times x minus h squared plus k. I don't know that you use this form a whole lot in Algebra 1. We'll definitely be looking at it some in this chapter, though. And this is called vertex form. It's actually a really handy form to use once you learn a little bit about it. So I think as we go through, it won't be till we get to Monday, but in lesson 4:1, we'll be graphing a lot with vertex form when we get there. Then in 4:2, we'll be graphing more with standard form, which I forgot to tell you guys at the beginning of the period. So we're going to do as much as we can in lesson 4:1 today. We're not going to get through all the notes, which means homework is not due on Monday. It will be due Tuesday because we're going to have a lot of notes left to do on Monday. So it'll probably be like a full day of notes Monday, homework due Tuesday. So if you don't want to look at over the weekend, you don't need to. Okay? Now, we are going to look, first of all, notice it's of the form f of x equals ax squared. So the ones we are looking at right here, ax squared. So there's no terms added or subtracted. Now, if we don't know what something looks like, what do we tend to do to find the graph? Like if I don't know exactly where to graph something or how to graph something.
We start at 0. That is not correct.
I'm just trying to decide how I want to use that. So start at 0 what?
0, 0.
Do we know we start at 0, 0?
Yes.
How?
Because it has to go through the middle. I'm saying something else.
I was trying to lead you here. Okay, I'm trying to lead you.
We start at 0, 0 because...
But how do I know that this graph goes through 0, 0? Do we know this graph goes through 0, 0? Do we know what points this graph goes through? Not yet. How can we decide some points that this graph goes through? Plug them in. So how about we set up an XY chart? That's all I was trying to get you guys to go to. Sorry, I took the long way there. So, if we plug in 0, and I picked 0 because Stella was using 0, right? But I'm going to go with 0 is always the easiest number to plug in anyways. 0 squared is 0. 0 times anything is 0. So we do actually have the point 0, 0, which in a parabola that is just an x squared term, there's no plus or minus, what is this 0, 0 going to be? Yeah, what is that main point thingy called?
The vertex.
The vertex. Good. Okay, so the vertex is 0, 0. And all these parabolas that we're graphing at this moment, because they're just ax squared, no plus or minus, our vertex is always going to be 0, 0. Okay, after we plug in 0, what's another good point to plug in? 1. So if we plug in 1 here, 1 squared is 1 times a half. 0.5 or 1/2. Now, what do you guys think about that? Do we like graphing fractions? Probably not. Okay. Normally, I know we love to plug 1 in. I'll be honest. I probably wouldn't use 1 on this one. Why would I not use 1? Yeah, it gave me a fraction. Okay, let's try 2. So, plug in 2, so that means I'm doing 1/2 times 2 squared. Remember, always do your exponents before you multiply. So 2 squared is 4. Half of 4 is 2. Oh, 2 2 is a much better number, ordered pair, isn't it? Okay, what's next? 4. What about 3?
3 works because you can get 9. It's not
Okay. Okay, so technically, could we use 3?
Yes.
Yes, in the same way that we use 1, we could use 3, but you're going to get a fraction. What kind of number should I be using here?
Even.
Okay, even numbers, multiples of 2. Here's my rule of thumb. If I have to multiply by a fraction in a situation like this, look at my denominator and pick multiples of that denominator. Since this denominator was 2, multiples of 2. So I would use 2, 4, 6, 8, 10, 12, but stay away from the odds in this case. Okay, so 4 it was. 1/2 times 4 squared. 4 squared is 16. Half of 16. 8. And so this ordered pair? 4, 8. Now, that's enough for me. I got my vertex and 2 extra points, so that'll be good. I'm going to set up my graph. Now, as I set up this graph, you will notice I'm setting up my x-axis low because all of my y values are going up. So I know my whole graph is going to be above the x-axis. When I label here, I'm going to label out to 4 left and right because I know I have to be able to go out to 4. And I'm going to label up to 8. Okay, start graphing when you're ready. We have a dot at 0, 0. We have a point at 2, 2, which says I'm going to go right 2 up 2. And I have a point at 4, 8. So I'm going to go right 4 up 8. What's wrong with my graph here? It's not a parabola. What are you thinking, Dylan?
You have to reflect it across the y-axis.
Yeah, reflect it across the y-axis. What do we know about the 2 halves of a parabola?
They're equal.
They're equal. What's the geometry?
Congruent.
Congruent. When you flip something over a line.
Symmetrical.
Symmetrical. That's the word I was looking for. I agree with all of them. They're congruent. It's a reflection. It's, I agree with everything we said. I was looking for symmetric, though. Okay? So if you recall, there's a line of symmetry in a parabola that goes through the vertex. And that line of symmetry, everything on the right is the same as everything on the left. So if I had a point that went 2 to the right and 2 up, I also have a point that goes 2 to the left, and 2 up. If I had a point that went 4 right and 8 up, I also have a point that goes 4 left and 8 up. Notice, did I put all those ordered pairs on my chart? No. I'm going to find, the easiest way to do parabolas in my opinion is I'm going to find 1/2 and then I'm going to reflect it. It saves me a little bit of work. When you draw this, do your best attempt to make this U-shaped as opposed to V-shaped. In other words, that bottom is rounded, not pointed. It's like mine's a little lopsided, but you get the idea. So a little bit of vocabulary here, a little bit of labeling, that is the vertex. We sometimes draw in the axis of symmetry. Remember, to draw in the axis of symmetry, it's a dotted line that goes through the vertex. And in this case, my axis of symmetry is the y-axis. You guys know the name of that equation? Or what is the equation for the y-axis? Because vertical lines are always x equals a number, and this goes through 0, 0. So this is the line x equals 0. So I forgot to write it up here, but the other vocabulary to go with this problem, axis of symmetry, x equals 0. And again, there will be problems in homework where you have to answer what is the vertex, what is the axis of symmetry. There'll be problems when you graph and you have to answer that. There'll be problems where they won't ask that. So just trying to get all the vocabulary for you guys. Okay. Questions on A?
No.
Is it coming back to us a little bit? Some of the details about this? Okay, let's try B. Practice what we just did. This time, it's what is the graph of f of x equals -1/3 x squared. Could you tell me the vertex? 0, 0. Because it's an x squared term only, no plus or minus terms. I know my vertex is 0, 0. If my vertex is 0, 0, what must be my axis of symmetry? X equals 0. Your axis of symmetry, here's another hint, is always x equals the x value of your vertex. Since the x value of my vertex is 0, that makes it x equals 0. So axis of symmetry, x equals 0. Now, for these, like the first one, we're going to talk XY chart. Even though we've already talked about it, I'm still going to put it on here. Easiest number, always to include, is 0. And when you plug in 0, it is 0. There's my vertex. I need 2 other points. What do we want to use? 3 and 6?
Yep.
Why are you guys picking 3 and 6? Okay, so I'm going to have to multiply by a third. I want numbers that are going to divide by 3 nicely. And so multiples of 3. So 0, 3, 6, 9, 12, 15. Not that we need to go that big. Whoops. Okay, that is supposed to say 6. Okay, so if we put in 3, I'll write the math down here. It's -1/3 times 3 squared. 3 squared is 9. -1/3 times 9. -3. To do a third of something, you're dividing by 3. Or if you prefer, you can make this 9 over 1. Multiply across, 1 times 9, 3 times 1, 9 over 3, and 9 divided by 3 is still 3. Negative times a positive makes it negative 3. Okay. Now we're plugging in 6. Negative 1/3 times 6 squared. 6 squared is 36. Negative 1/3 times 36. Negative 12, because 1/3 of 36 divided by 3, negative times positive. When I set up my XY axis this time, I'm going to put my x-axis at the top. Not that you have to, but I'm just trying to give you hints if you want the best way to make the most out of what paper you have available. I'm going to label left and right 6. I'm going to go down 12. Okay, you ready? 0, 0. 3, negative 3. So I'm going to go right 3, down 3. 6, negative 12. So I'm going to go right 6, down 12. And reflect them, right? Reflect them over that axis of symmetry, which is the y-axis. So I need to go left 3, down 3, left 6, down 12. Vertex again is at 0, 0. And if you have to draw in your axis of symmetry, it is a dotted line on the y-axis. And it would be the equation x equals 0. Okay, are we good on that? A little bit of information to review in the middle section here. The value of a makes the graph of f of x equal ax squared either stretch or compress. You remember from chapter 2, the list of all of our transformations? And when there's a number that multiplies out in front, it's either a stretch or a compress. That's what we're talking about right here, the 1/2 and that 1/3. Those are either stretch or compress. If a is negative, what happened on graph B when a was negative? It flipped down, doesn't it? And so when you have the situation such as y equals negative ax squared, that just means my parabola is going to be upside down. If a is positive, then that means the graph goes up. So if y equals positive ax squared, that means I'm going to have a right side up parabola. If a, that number out front, is a fraction between 0 and 1, is that stretch or compress? If it's between 0 and 1, that is a compress. Remember, compress means I think of it as compressing the graph down. When you compress the graph down, it essentially makes it look wider. So there's your compressed, which is what we did up top. If the a value is a number greater than 1, then the graph is stretched. Now, going into the back side, we are going to review these translations. Again, this is all chapter 2, guys, but I used it in chapter 3 also, I believe. We keep talking about this stuff. You guys remember if when you add and subtract c, what happens? If it's f of x plus c or minus c, and I use the expression, I say it if it's at the end of the equation. It's not that it technically has to be at the end of the equation. It can be anywhere. But if it's away from the x, right? Not in with the x, but apart from the x. Then that's going to take the graph either up or down. If it's plus c, it takes the graph up. If it's minus c, it takes the graph down. And you've heard this from me a lot this year. So this is not new. Now, what changes when that plus and minus c is in the parentheses with the x? Now we're going left or right. And what's the catch here? I keep saying it. Opposite the sign, right? So if you see minus c inside the parentheses, we're actually going to go right c. If you see plus c in the parentheses, we're actually going to go left c. Okay, before we flip to the back side, I want to get down basic information of a parabola. So, if it's just f of x equals x squared, nothing special happened. What's the vertex? 0, 0. If my vertex is 0, 0, what's my axis of symmetry? X equals 0. Now, I would like to write down a basic XY chart that technically I'm going to tell you I want memorized because we're going to use it on the next page. So when I say a basic XY chart, just using the basic numbers. So of course, 0, when you put 0 in, 0 squared is 0. We already know that, that's our vertex. 1. 1 squared is 1, so we have the ordered pair 1, 1. If we put in 2, 2 squared is 4. So we have the ordered pair 2, 4. That is your basic parabola. That is really good to just know. This is what my parabola looks like. So if I sketch a graph here, nothing fancy, but again, just basic parabola information. I'll be able to go left 2, right 2, and up 4. So, 0, 0, right 1, up 1, right 2, up 4. You know if you go right 1, up 1, we also have to go left 1, up 1. If we go right 2, up 4, we have to go left 2, up 4. We've already talked. And that point right there, that 0, 0 is my vertex. And on all of these we've done so far today, the y-axis is my axis of symmetry. So going into the next page, what I need you to know, a basic x squared parabola. If your vertex is at 0, 0, the first set of points go over 1, up 1. What do the other set of points do? Over 2, up 4. Know that. That's the easiest thing I could say there. And it's not hard. I mean, you'll get used to it. You'll know it. Okay, do we have what we need here? Okay. So notice what it says here in example 2 on the back. Graphing translations of f of x equals x squared. So this is where I want you, this is why I want you to know what that x squared looks like so much, because we're going to take that parabola and move it. And if you know those numbers, it's much easier to move. Okay, if my parent function is f of x equals x squared, what do you guys know about f of x equals x squared minus 5? Do you guys agree with Maggie? The number is away from the x, so it's up or down, direction of the sign. So first thing one of the things it says is how is the graph translated? It translates, so I'm going to write it out, translates down 5 units. So Math Excel, I think you have to pick some of those where they ask what are the transformations here. Now we're going to graph this. So I'm going to set up my XY axis here. This one I'm going to more center. As I set mine up, I need to be able to go 2 left and 2 right. Now I'm going to go 5 up, 5 down. Or technically you could go 4 up and 5 down, but different people will do these problems different ways. Because we are graphing a translation, I'm going to use that fact that this moves down 5 to my advantage. Before I move that, though, can you put the basic dots for the basic parabola on your graph? Do you remember them? And I'm just doing this in pencil on mine, so lightly on yours, however you want to do it. But I know normally my vertex will be 0, 0. From that 0, 0, my first set of points are over 1, up 1, both directions. And my second set of points go over 2, up 4. Now, I'm not even going to connect those dots, but that is my starting parabola. That is x squared. What do I do with that starting parabola?
Translate it
Down 5. So generally speaking, what am I saying?
Moving your point, moving down 5.
Taking each point and moving it down 5. Now, I'll be honest, I don't do it exactly that way. My suggestion, start with your vertex and move it down 5. So here's my vertex, 1, 2, 3, 4, 5. There's my new vertex. Now, if you want to move each of your other dots down 5, that's fine. Here's what I think. Basic parabola. From my vertex, what do I do? Over 1, up 1, and over 2, up 4. That's how I like to teach it. If you don't like that, then move the individual dots. So over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4. Eventually, I will not put those original dots on my chart. Okay, the original 0, 0, 1, 1, 2, 4, I won't put those on there if it's just me doing it. And eventually I want, I think you guys can get to that point. If you don't like how I did it, then that's fine. You can do it slightly different. Questions on that one? Okay, let's do B. B is f of x equals x minus 4 quantity squared. What are your thoughts on what's happening with this one? Okay, that minus 4 is in the parentheses, makes it left or right. Opposite the sign, as she said, right 4. So I'm going to say translates right 4 units. Now, since I know it needs to translate right 4, when I set up my graph, I'm going to have more room out to the right. Yeah. For me, I set mine up so I have the ability to go 2 left, 6 right, and 4 up. Now, if you don't feel the need to do this part, then don't. But I'm going to put my 5 original dots on. My 5 original dots go at 0, 0. Where do you go from the vertex? Over 1, up 1, both directions, and over 2, up 4. What do we do with all 5 dots? Right 4. My suggestion, start by translating the vertex. Right 4. From that vertex, what can I do? Over right 1, up 1, and over left 1, up 1. Besides 1, 1, what's my other set? Over 2, up 4. Left 2, up 4. Which there is already a dot. It was originally the right side of the parabola, now it's the left side of my new parabola. Okay, so what is this new vertex? What ordered pair is that? 4, 0, because we moved right 4 up or down 0. If my new vertex is 4, 0, what's my axis of symmetry? X equals 4. And if I draw in that line x equals 4, is my parabola symmetric around it? Okay, it should be. Now, that is a perfect stopping place. On Monday, we will pick up there, and on Monday, the first thing I'm going to ask you to do is C and D. We'll see how much you guys can remember. Homework, you're welcome to start, but honestly, I wouldn't worry about it too much because we'll have a lot to do on Monday.